All right, welcome back, y'all. This is the question that we're going to attempt, right? Firstly, before we write what we are given, let's start by assessing this question and checking how they wanted to trick us. Because in every question, they will always want to trick you, right? So, what? We have a pulley here. This is a pulley, right? And then there's a gear set. We have a gear here. This is a gear. This is a gear, and then here we have a pinion. This is a pinion, right? And then what? This is the driver. This is the driven, and then we have a pulley here. So the torque that is being applied, that is being produced by the pinion, is not the same as the torque that is going to be produced on the shaft, because the shaft is attached to the gear alone, not to the pinion, right? Okay, and then the pulley, the tensions that are being pulled on the Z side. You see how they drew it on the side? But then you have to realize, you have to assess it and be able to see that these tensions that are being pulled on the Z plane, they're not being pulled on the X plane. Yeah, that's one thing you have to look at too. And then what? Yeah, so we're just gonna have to find the torque here, transfer it here, and then okay, I'm making it sound easy, but then okay, it's not easy, trust me. So first things first, let's write what we are given. We're just gonna write what we're given, right? All right, okay. Bear with me. Did I even greet you guys? Oh, yeah, no? That's how stressed we are. It's test week. Yeah, next week we're writing it, so bear with me. But then Dumelang, yeah, Sanmanani. How are you? Salam alaikum. I hope you're all good. Okay, what are we given? They say a single reduction gear system is to transmit power 4.2 kilowatts, right? We're given power, it's called 4.2 kilowatt, right? At a constant speed, right, of 160 RPM. Here they made a mistake. They wrote they wrote W, which is the angular velocity. I think they should have written N, so because of the units RPM. So the speed we given, speed as in 1360 RPM, right? And the open spare gear system consists of a 20 degrees pressure angle, right? And then the pressure angle we have is 20 degrees with a modulo of blah 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 blah. All this, most of the thing that we're given is to design the gear. But then right here we're just designing this shaft, right? So the only thing that we're going to need is the power, then the speed, and then that pressure angle, right? Okay, let's go straight into business. Straight. And bear in mind, this power and speed, like, is of the pinion, so you shouldn't confuse it. I don't know if they, okay, let me just check. But then you have to be able to assess it. You have to be smart about it. Don't just go into rush and just write things not knowing what's happening, because it will cost you. Believe me, it will, right? Like they're written, this is the driving shaft, right? I hope you get me. But then let's just start. Okay, let's try a solution. This is gonna be a long solution, so bear with me, right? You're gonna need a monster for that. Right, solution. let's start by calculating the torque of the pinion, right? T is equal to 60p divided by 2p, and I'm gonna rush things, right, so that I can make the video a little bit shorter, right? Okay, torque of the pinion, T is equal to 60p. The power we're given is 4.2 times 10³ divided by 2 pi, and given was 1360. So the torque of the pinion is what? 64.2 times 10³ divided by 2 pi n, which gives us 29.49 Newton meter, right? Okay, let me check if the speed I got it correct. Yeah, 4.2. Damn, the torque is very small. But then, okay, it's what we're given, so we work with what we're given, right? After getting the torque, let's find the tangential load, like the tangential load that is acting on the gear, that is the Ft. Last time I said, what is Ft? Ft is equal to, well, Ft is equal to power. You can either write it as power over speed, right? Or you can write it as what? Let me try to remember this. The tangential load is equal to the torque. Yeah, the torque. Bro, why am I forgetting this? The torque over the R. Do not forget, okay? Right, let me just find this. Tangential load is equal to, now I have this torque I calculated, which is 29.49, right? Over R. And what is this R? R is the R of the pinion. Are we given what the pinion, the diameter of the pinion or anything? Let me check. I'm just want to check everything. If we're given the diameter of the pinion, check the question. Yo, you're supposed to calculate it. Like I said, this is number B. So in the first question, where we have to design the gear, right? We're supposed to calculate the diameter of the pinion and the diameter of the gear. Okay, how are we supposed to calculate the diameter of the pinion? The diameter of the pinion is equal to the module multiplied by the number of teeth. What are we given? Yeah, the number of teeth we given. Number of teeth of the pinion, we're given number of teeth of the pinion multiplied by the module, right? The number of teeth of the pinion is what? Is 22. And then what is the module? Module is 3, right? So that means the diameter of the pinion is 22 multiplied by 3, right? Which is 66 millimeters. But then I love my things in meters, right? 0.06 meters. That means RP will be 6. Okay, did I say 0.06? No, 0.066. Hey, yeah, 0.066. 66 divided by 1 times 10. 0.066, yes, and then we divide it by 2. We find the radius, which is 0.033. It's easy to make mistakes. It's easy, but then to bounce back. Okay, 0.033. 0.033, which is our radius, right? And then let's find the tangential load. So one thing you have to know, the tangential load on the pinion is the same as the tangential load on the gear, and the radial load on the pinion is the same as the radial load on the pinion and the gear, right? It's because the same gear set. So if you find using this ones, you also got one. Okay, I hope you understand. So this is gonna be 29.47 over 0.0 3, right? That means our tangential load is 893.03 Newton. Yebo, mashallah. Okay, now we found the tangential load, right? We're going to find the radial load. Radial load. Right? And then the radial load, what did I say is radial load is equal to the tangential and then tan multiplied by the pressure angle. Last video I said this is an angle of contact. This is not the angle of contact, it's the pressure angle. They are not the same, right? So it's gonna be, we find the tangential here, it's gonna be 893.03 tan 20. We're given the same, it's 20 degrees. Like I said, it's easy to make mistakes. So when you're writing a test, you gotta be as focused as what? Gotta be focused as a lion chasing an impala. Okay, what am I saying? Okay, 0.036 Newton is a force. Yeah, it is. So it's 325.036 Newton, right? Okay. Now we found the radial and the tangential load, like, on this gear, right? And then what are we supposed to do from here? Oh yes. We're gonna find the torque on the shaft, which is the same as the torque on what? On the gear, right? This is the radial force on the gear and on the pinion, and then also the tangential force on the gear and on the pinion, right? But I hope I'm correct, but then I trust myself, right? But the torques are not the same, even though they have the same forces, right? But then the torques are not the same. Why? Because the speed, they're different. Listen, wow, this is confusing. But then I hope you get me. I hope you all get me. So we have to find the torque here, the torque of the gear. Yeah, the torque of the gear, right? And then how do we find it? We know that the gear ratio. Are we given the gear ratio? Speed. Oh, we're given the speed ratio, and the speed ratio is the same as the gear ratio. Why? Because it's mg, right? It's equals to ng over np, right? Is equals to the speed. This is the number of teeth, right? And then it's equals to the speed of the pinion, right, over the speed of the gear, right? Is equals to the torque, yeah, of the gear over the torque of the pinion, right? And then it's equals to the diameter of the gear over the diameter of the pinion. Yes, yeah, this is real nigga stuff, real nigga shit, right? And then we know the speed ratio. The speed ratio is 2 over 1, right? And then now what do we need to find? We need to find the speed, or we can automatically find the torque, right? Okay, this is the torque of the gear, which is the one we want, right? And then we know the torque of the pinion. The torque of the pinion, we calculated it here, which is 29.49. So the torque of the gear is equals to 2 multiplied by 29.49, which is TG, right? 2 times 29.49 is 58.98 Newton meter. Torque. is in Newton meter torque, right? Okay, we're done with the torque of the gear. So the torque of the gear is the same torque on the shaft, and it's gonna be the same torque on the pulley. We're getting there, bit by bit, brick by brick. I built this shit. Okay, sorry for that. I watched Snowfall, so that's why. But then yeah, let's focus. So this is the torque of the gear. So the same torque of the gear is gonna be the same torque on the pulley, and it's gonna be the same torque on the what? On the shaft itself. I hope you understand me, right? Okay. We found. So basically we're done with the gear. Yes, I think we're done with the gear. Okay. Yeah, we're done with the gear. Because we found the tangential, and we found tangential, we found the radial. So next, what is our next step? We want to focus on the pulley, right? Focusing on the pulley, we want to find tension 1 and find tension 2, right? And then we'll solve the reactions, and then we find the maximum bending moment, and then bro, this. Okay, let me do the pulley before I end this video, because I don't want it to be that long. Okay, let me say the pulley, right? You want to do this as fast as we can. The torque, right, is equals to T1 minus T2 multiplied by the radius of the pulley, right? And the torque we have, which is 58.98, right, is equals to T1 minus T2 and multiplied by the radius of the pulley. Are we given? Please give me, bro. Please. I'm still checking if we're given the radius of the pulley. Come on. That is, are we not given that? Okay, let me just check. The question. Check the question. If we're not given the radius of, but I think we're given, because the radius of the pulley, are we given? Okay, I'm still checking it. Bear with me. We're given list for. Okay, on this question I don't see the radius of the pulley, so I'm gonna end this video here, right? And then I'm gonna check if the question was well structured, because I think we're supposed to be given the radius of the pulley, but then on the question paper we're not given the radius of the pulley. So I'm gonna double check on the question paper, right? Because sometimes these guys, they make mistakes, right? They're people just like us, right? But then these are the first steps that we're gonna have to do, right? Here we have to be given the diameter of the pulley. We have to, is a must, right? So I'm gonna double check on that, and then on the next video we picking up from here. I think I'm gonna make this a 3-video question, but then a little bit smaller. So yeah, I'll see you in the next video. I'm out.